Chapter 5, Section 6, Indirect Proofs and Inequalities in Two Triangles. An indirect proof is a proof in which you prove that a statement is true by first assuming that its opposite is true. If this assumption of the opposite leads to an impossibility, then you have proven the original statement is true. So to write an indirect proof, we're going to take the statement that we're trying to prove, and what we're going to do is we're going to take the opposite of that, and we're going to prove that that is impossible. By proving that that is impossible, in turn we've proven that what we are trying to prove is in fact true. An example of an indirect proof. This says use an indirect proof to prove that a triangle cannot have more than one right angle. Notice I've already gone ahead and drawn a triangle ABC. What we are trying to prove is that a triangle cannot have more than one right angle. If we're using an indirect proof, though, we first need to assume the opposite of that is true. So what we're going to assume is true is the opposite of a triangle cannot have more than one right angle, which is a triangle can have more than one right angle. If we can prove that this statement is false or impossible, then in turn we've proven that what we are trying to prove, a triangle cannot have more than one right angle, is true. Go ahead and there's several different, you can choose whichever angles you want to. For this example though, I'm going to assume, because I'm trying to prove that a triangle can have more than one right angle, I'm going to say that the measure of angle A and the measure of angle B are both 90. That means that they're both right angles. But if you think about a triangle and its angles, we know that the three angles of a triangle need to add up to equal 180. Well, if you have two right angles, in this case I'm assuming A and B are right angles, then just the measure of angle A plus the measure of angle B equals 180. If only two of the triangles, of the angles in a triangle, take up the whole 180 degrees for all three angles, that means that the sum of all three angles of a triangle is 180, so that would mean that the measure of angle C, or the third angle, would have to be 0. But this is impossible because the angle measures of a triangle have to be greater than 0. So we can conclude that the original assumption is false that we started with. Triangle ABC cannot have more than one right angle. By proving that my assumption, a triangle can have more than one right angle, is false, I've proven that triangle ABC cannot have more than one right angle. What I want you to know about indirect proofs is that to write an indirect proof, you have to first assume that the opposite of what you are trying to prove is true, but then prove that statement, so prove the opposite, to be impossible. So what I'm saying is, we're going to practice writing indirect proofs. The key pieces of an indirect proof that I need you to know is that to write an indirect proof, you have to take whatever statement it is you're trying to prove and assume the opposite of that first. In order to prove the original statement, you have to take the opposite statement and prove that it is impossible. When you get to the point where it is impossible, you know that the original statement that you are trying to prove is in fact true. The Hinge Theorem says that if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle in the second, then the third side of the first is longer than the third side of the second triangle. The converse of the Hinge theorem says that if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. Examples 1 through 4, they're asking us to complete with less than, greater than, or equal to. If you look at number 1, they're asking us to compare the two sides AB and DE in the two triangles provided. If you notice, we have two triangles with two congruent sides. AC is congruent to side DF, and CB is congruent to side FE. Notice that the included angle in triangle ABC is 100, and the included angle in triangle DEF is 90, or a right angle. Because angle C is greater than angle F, or is larger than angle F, that means that the side opposite of angle C is going to be larger than or longer than the side opposite of angle F. The side opposite of angle C is side AB, and the side opposite of angle F is side DE. So what I can say for number 1 is that AB is greater than DE, and the reason is, it's the Hinge theorem, is that 100 degrees is larger than the 90 degrees included between the two congruent sides, so AB has to be greater than DE. If you look at the second example, number 2, we're trying to compare the measure of angle 1 and the measure of angle 2. Again, if you look at the two triangles that were provided, notice that angle 1 and angle 2 are the included angles between two congruent sides of two triangles. So angle 1 and angle 2 would be the included angle. Angle 1 is opposite a side that measures 6, and angle 2 is opposite a side that measures 4. Remember that the angle opposite the larger side has to be the larger angle. So in this case, the measure of angle 1 is greater than the measure of angle 2. If you look at number 3, again we're given two congruent sides. Angle 1 and angle 2 are included between those two congruent sides in the two triangles that were given. And notice angle 1 is opposite a side that measures 11, and angle 2 is opposite a side that measures 11. Because angle 1 and angle 2 are opposite of two sides that are equal, that means that the angles are equal. If you look at number 4, we're trying to compare the two sides AB and CD. If you notice, these two triangles are sharing side CA, so by the reflexive property we can say that CA is congruent to CA, or that side is congruent to itself. So we can use the Hinge theorem. The 44-degree angle and the 42-degree angle are in two triangles and included between two congruent sets of sides. Notice that angle C would be measuring 44 degrees, and angle A is measuring 42 degrees. CD is opposite the 42-degree angle, and AB is opposite the 44-degree angle. Because AB is opposite of a larger angle, because of the Hinge theorem, I can say that AB is greater than CD. The next example says that in triangle ABC and triangle DEF, AC is congruent to DF, BC is congruent to EF, AB equals 11, ED equals 15, and the measure of angle F is 58 degrees. Which of the following is a possible measure for angle C? 45, 58, 80, or 90 degrees? This is almost an impossible problem to do without going ahead and drawing yourself a picture. So I'm going to start with two triangles. I have triangle ABC and triangle DEF. I'm going to go ahead and mark what they've told me. What they tell me is that AC is congruent to DF, so I'm going to go ahead and mark that with my tick mark. One tick mark means that they're congruent. It also tells me that BC is congruent to EF. This time I'm going to put 2 tick marks to show that BC is congruent to EF. They also tell me that AB is 11 inches and that ED is 15 inches. The last thing that they tell me is that the measure of angle F is 58 degrees. Their question is, which of the following is a possible measure for angle C? So I'm trying to find a possible angle measure for angle C. Notice I am going to be able to use the Hinge theorem. The 58-degree angle and angle C are included between 2 congruent sides in 2 congruent triangles. Or in 2 triangles that have congruent sides. Notice that 58 is opposite a 15-inch side, and angle C is opposite an 11-inch side. Because 15 is greater than 11, that means 58 needs to be greater than the measure of angle C. If you look at the choices that they've given us, there's only one measure that is less than 58 degrees. So my answer is 45 degrees would be the measure of angle C. In this example, they say in triangle GHI and triangle JKL, GH is congruent to JK, HI is congruent to KL, GI equals 9 centimeters, the measure of angle H is 45 degrees, and the measure of angle K is 65 degrees. Which of the following is a possible length for JL? Go ahead, just like in the last example, I need to go ahead and draw myself a picture. So I have triangle GHI and triangle JKL. Mark what they've told you are congruent. So I'm going to mark that GH is congruent to JK. I'm also going to mark that HI is congruent to KL. I'm also going to say that GI is 9 centimeters and that the measure of angle H is 45 degrees. The measure of angle K is 65 degrees. Which of the following is a possible length for JL? Notice JL is opposite of angle K, which measures 65 degrees, and your 9 centimeter side is opposite the 45 degree angle. If you look at the choices that they've given you, we have 5, 7, 9, or 11. 45 degrees is less than 65 degrees, which means that the side opposite of your 45 degree angle 9 centimeters needs to be less than the measure of angle JL, which is opposite of your 65 degree angle. The only number up there that they've given us for a possible length that is greater than 9 is the 11 centimeters. So our best choice for this question would be 11 centimeters. Today's assignment is on page 305. It's numbers 7 through 24 all.